We had a bit of a technical hang up there that we had to work our way through. So I want to welcome Dave Goldsmith with Plygem and Anton Van Dyk with JRS. Anton unfortunately couldn't get to Toronto, but he is online with us, and he's going to be participating in this session on managing acoustic expectations. So Dave, you have a mic? Check, check. Check, check, check.
Check, check, check.
Yeah? Okay.
Check.
There you go. You're good.
Yeah, so the topic, today's topic is managing acoustic expectations in fenestration. My co-presenter is Anton Van Dyk of JRS Engineering. I'm Dave Goldsmith with Cornerstone Building Brands. And so, first slide, why do products need acoustical ratings? And this is all about the BC experience. So, they're doing some long-range planning in BC, and they have a program called Metro 2050, which is Vancouver's regional growth strategy. And so Metro Vancouver is a federation of 21 municipalities, one electoral area, and one treaty First Nation, working collaboratively in planning and providing vital utility and local government service to about 2.75 million residents. Essential services include the provision of drinking water, sewage treatment, solid waste disposal, along with regional services like parks, affordable housing, land use planning, and air quality management. So their guiding principles is number one, to put growth in the right places. Number two, to protect important lands. Number three, to develop complete communities. Number four, to provide affordable mobility, housing, and employment choices for all. And number five, support the efficient provision of infrastructure. And so as a part of this, they have created what they call major transit growth corridors. And so those are select areas along TransLink's major transit network within which member jurisdictions in consultation with Metro Vancouver and TransLink may identify new frequent transit development areas. So these corridors shown on this map 5 extend approximately 1 kilometer from the roadway center line in both directions and do not extend outside the urban containment boundary. And so if you see here in yellow, you've got the major transit networks. And I don't know if this thing, whoops, didn't mean to do that. And so you see in yellow, those are the major transit networks. And in blue, surrounding them to a kilometer each side, is the major transit growth corridors. And their plan is to build up and do multifamily housing in these corridors where everybody has quick access to transit. And, you know, even that 15-minute city concept and right around every transit hub. And so what does that look like? I mean, for here example is Vancouver, a slide showing Vancouver's Broadway plan densification. And so that is Broadway. And they're planning on building up in blue on either side of Broadway. Broadway is a major road. And then you see the illustration to the right, the concept of you got the transit station and everybody's living in close proximity to the transit station. If they don't actually work at that area, they can take transit. But, you know, they want people to be working close to where they live is the vision. But these visions come with certain consequences. So now this slide here is an Anton provided slide. And so basically, as a general principle, municipalities are not allowed to pass bylaws regarding anything that's already covered under code. But if code does not address something, then they are allowed to pass bylaws. And Anton, do you have anything you'd like to say about this slide and the next?
Yeah, so the next slide is the Building Act slide, right? So just for context. So a couple scenarios. When Dave came to me with this issue, I kind of laughed inside a bit because I've been dealing with it for a decade in the Vancouver region. And as we start seeing more and more densification, what we've experienced is the development permit process. So in order for a developer to get a permit that basically gives them permission to put a certain type of building of increased density on a lot, they have to go through this development permit process. And one of the criteria of a development permit process is to do an acoustic study of the site. So in heavy corridor transit locations where traffic noise is going to be high, they set an expectation for the developer to hire an acoustical consultant who then is going to use industry standards to determine what that outdoor to indoor sound transmission acceptable levels are. So there's certain decibel level criteria, expectations for bedrooms, for living rooms, and different areas of occupancy of a building. And so that triggers basically the environmental separation design, the exterior walls, the windows, the roof, and all of those components to have certain types of ratings. Now, the important part of that conversation is it's part of the development permit, not the building permit. And this is what the building code says about acoustics in the National Building Code and in the BC Building Code. You'll notice a couple things here that are kind of glaring, that it doesn't really talk about outdoor to indoor acoustics. It talks about separation from any other space in a building. So if you look at sentence number 1, it also refers to STC. It doesn't refer to OITC. And if you understand the difference between those two, OITC is outdoor to indoor transmission and STC is just sound transmission. And the main difference between the two is OITC deals with different frequency levels, which plays a significant role in how sound moves through an assembly. So it's really important to understand this is all the building code expects. This is all that is required to be coordinated by the architect. This is all that's required to be verified that it is accomplished in order for the building to reach its occupancy. So the question always comes down to is what weight does the development permit requirement have over the building permit? And what would you do in a situation where a development permit requirement by a municipality, you can have Vancouver, Burnaby, Surrey, and all these different regions have their own different development permit criteria. What would you do if it caused a conflict with the building code? And so, Dave, can you go to the next slide? So got a bit of a backstory to this next slide is I had to travel to Victoria. This is probably 2014, 2015 to do a presentation to the Builders Association in Victoria. And on my way, or at that meeting, we were talking about the introduction of the Energy Step Code coming into the BC Building Code. A lot was transforming in the British Columbia Building Code at that time. And what was going on is it's important to understand the purpose of the energy codes that we have in these step codes as it relates to this, because it goes to the purpose of codes. Why do we have building codes, and why do we not have all these other bylaws out there going on? And I just happened to be talking to a group about the purpose of the energy step codes was to create one energy code that could be adopted by municipalities at different levels as they saw fit, not to have their own energy code. Because what was happening prior to energy step codes is every jurisdiction, every local municipality, depending on their feeling of the importance of energy in the building code, they were writing their own bylaw. And it was wreaking havoc. One builder was building in Vancouver. It had a code that's a bylaw that said X. Another one was in Burnaby, it had a different bylaw. Nobody could keep track of what municipalities were. So the Minister of Housing revised the Building Act, which says basically a local building requirement other than a local requirement, sort of little aspects here. But basically what this says is that municipalities cannot have their own bylaws. It's illegal. It's against the law. This is an act. This is a law, not a building code. And so when you have a development permit requirement that requires an acoustic requirement that then impacts an assembly on the exterior of a building, what happens when it conflicts with a building code requirement? And the story I tell is a project I was involved with where the acoustic consultant had required laminated glass on the inboard light of the window to deal with the OITC rating, but the glazing engineer wanted tempered glass in order to deal with guard load and fall protection of the window. So you now had a situation where the acoustic consultant that was regulated under the development permit process was providing a specification that conflicted with a life safety requirement that was required under the building permit process. And so, long story short, it took weeks to sort out. And at the end of the day, it all lands on the architect, which we call the coordinating registered professional, to sort through. So I bring this up because it's really, really important that the fenestration industry understand the role they play in this. because what's happening in the industry, in particular in British Columbia with this issue, if you're not seeing acoustic requirements in your region, you will, as we see more densification. But what's really happening is everybody's downloading this responsibility to the manufacturer, which is wrong, in my opinion. This is something that is mandatory, has to be coordinated early. One of the big issues that we have with this is the acoustic consultants are hired at the development stage. They dictate the requirement for glass. And then the manufacturer is required to hire a structural engineer to design the glass after contracts are signed. So there's a massive disconnect as to when these design issues are being done. And usually they create conflict at the time when everybody says, just get those windows ordered. What's taking so long? What's going on? So what was happening on the project I had is everybody turned around and says, well, you should provide tempered lamy then. And I'm like, well, who's going to pay for that? And are you aware of the optics that creates with the glass? And so we were dealing with these issues while the general contractor basically wanted windows delivered in 2 weeks, and nobody was making a decision on what was basically most important. Long story short, that was a bit of a long story, so I'll shorten it up. It came down to who was signing off on what. And go back, Dave, to the other slide. The architect had to hire a code consultant, no, backwards, had to hire a code consultant who basically came back and said, you're only required as an architect to sign off on requirements that are in the building code. You are not obligated to sign off on requirements in the development permit. So when you, I don't know if you can go back, Dave, that section of the building code that only requires acoustic requirements from indoor to indoor, like a mechanical room to a suite or suite to suite, that is the only requirement that the architect has to sign off on. There is no requirement for sign off on outdoor to indoor acoustics to meet occupancy for a building. So knowing that, as soon as I knew that and understood that position, everything changed for me in how I communicated this to my clients and went through it and understood how to manage this conflict. And I, in a way, became an advisor to architects on this issue because most don't understand this. And they feel that they have to cater to a development permit. But the whole purpose and the reason why we have this building act that does not allow municipalities to have their own bylaws is because they cause conflict with building code. They can create scenarios where life safety issues aren't met or energy requirements aren't met because no one's coordinated these issues preemptively as code writers will do so. So that gives a bit of a background to understanding what role we play as a fenestration industry in dealing with this scenario. And there's a ton of education that needs to be had backwards to acoustical consultants and architects on the impact acoustics has on IGU design that can then impact life safety, glass selection, airspace design, and the impact that has on thermal performance. So Dave, I'll hand it back to you.
Thank you, Anton. Very good. So I want to give you an example project that we were quoting on East Broadway. And so this is a multifamily apartment complex. And this is the example. The project site is on East Broadway, and basically you've got four houses that are being knocked down to create the lot for this multifamily development. And so who sets the acoustical requirements? Well, believe it or not, City Council and the mayor have to pass a bylaw with respect to that one parcel of land. Okay, and so it says, see CD1 there, the area shown within the heavy black outline on Schedule A is hereby designated CD1. And so later on in that bylaw, you get to the requirements for acoustics. Okay, and it says a developed permit application must include an acoustical report prepared by a registered professional acoustical engineer demonstrating that the noise levels in these portions of the dwelling units listed below will not exceed the noise levels expressed in decibels set opposite to such portions of dwelling units. And so this is the A-weighted 24-hour equivalent sound level and will be defined simply as noise level in decibels. And so the maximum noise level in decibels for bedrooms is 35 decibels. For living, dining, and recreation rooms is 40 decibels. And for kitchens, bathrooms, and hallways, that's 45 decibels. So, but where did they get this from? So there was a publication by CMHC, Road and Rail Noise Effects on Housing, first published in 1977 and revised in 1981. Price $6. That'd be like $600 today or something. Anyway, so this is it. And so what they're doing here is they're telling you about decibels, noise levels. And basically, if you go up or down 10 decibels, you're increasing the sound pressure by a factor of 10 or decreasing the sound pressure by a factor of 10, although the perceived noise level is not going to be different because of our way our senses and our brain filter out so that we're not absolutely destroyed mentally when an airplane goes overhead or a train goes by. But so basically, their base reference is 70 decibels. And that would be like highway traffic at 15 meters, and it's unacceptable. So they've got the range on the side of what's unacceptable and what's acceptable, and that level is unacceptable without adequate sound insulation. So now, if you go down to 60 decibels, it's half as loud. 50 decibels is quarter as loud. That's a noisy office. And you could have potentially speech interference, so it's normally acceptable. Then a public library would be 40 decibels, and a soft whisper at 5 meters would be 30 decibels. And then they go on to say a few things. An appropriate outdoor noise level is 55 decibels, which would correspond typically to an indoor level of 40 decibels. These levels would prevent conversation at close range or in a slightly raised voice most of the time. So to meet their criteria of acceptable noise levels, the levels given in Table 1 are recommended. And again, this is exactly where they've copied this from this 1977 document into their municipal bylaws. And so under that system, they had they didn't have OITC. What they had was a required acoustic insulation factor, and it had to do with the level of noise outside the building, the number of components forming the room envelope, and the STC of those components. So it was not like a one number thing. Somebody had to go in there and they had to do some math to figure it out. And you still see this acoustical insulation factor on some projects, but not in BC where they have these bylaws. And so this is another publication that is referenced in that publication. Again, June 1979 and revised in June 1980. And it talks about the acoustic insulation factor. And so in North America, at the time, the most widely used rating for sound insulation of building components was STC. If the advantages of standardization were the only relevant concern, then STC would have been the logical choice as a noise reduction rating for the CMHC standards for insulation against transportation noise. Unfortunately, the use of STC in this type of application has several significant shortcomings. The STC was originally developed for rating the sound reduction of internal floors and partitions with sources such as the human voice, whose dominant sound energy is in the middle and high frequency ranges. However, there is no information to show that the STC properly rates the effectiveness of a partition for protection against other types of noise spectra, for example, a noise with a strong low frequency component. Because of this, the standard defining the STC specifically recommends against its use in applications involving the exterior walls of buildings. So now, what is an OITC rating? So OITC stands for Outdoor Indoor Transmission Class. It is a relatively new, around 1990, system developed to measure how products perform in keeping outside sounds from penetrating into your living space or office space. OITC ratings are calculated based on the transmission losses in the lower frequency ranges that are associated with outdoor sounds like road and rail traffic. And so, again, this I've copied some stuff out. And again, a development permit for application for dwelling uses must include an acoustical report prepared by a registered professional acoustical engineer. And so here is to the architect, from the acoustical engineer, appended is our report entitled 2037 to 2061 East Broadway Acoustical Evaluation. And again, there's the design criteria. copied straight out from the bylaw. And so what they actually do is they set microphones outside the building that's facing the main road, and they measure the 24-hour acoustical levels and its peaks, and then they work out what OITC ratings are required to give you 35 decibels in bedrooms and 40 decibels in living, kitchen, and decoration rooms, and 45 decibels elsewhere. And so typically at the end of the report, after a bunch of data, they will say what they're looking for. And so on this building facade, East Broadway, which is facing south, facing the road, bedrooms and studios, the window and door upgrade needs to be OITC 32. The exterior wall upgrade, I don't know how to read that, 2 times GBB on res. Maurice, what does that mean? 2 times gypsum wallboard. Thank you, Maurice. I don't know everything. I don't know. If it doesn't have to do directly with windows, I don't know shit. And then east and west building facades, they only require OITC 29 in bedrooms because they're on the side of the building, and they have no requirements on the back side of the building that's facing the alleyway. And so here's what they're saying is OITC 32, provide OITC 32 rated window and door assemblies, typically with 6 millimeter, 13 millimeter airspace, 6 lam thermal glazing, and OITC 29, the acoustical consultant expects that you'll be able to get that with 6 mil, 13 4 mil, or 6 mil, 13 6 thermal glazing. And for a long time, we just went along and did that. Then one day they said, can the manufacturer prove what the actual ratings are of the windows? Okay. So after we'd already shipped the windows, they did an addendum. And they say, you know, PlyGem submittals for building A and B indicate vinyl vista windows proposed with IGU consisting 6-on-6 glass. For their proposed windows, PlyGem to submit specified acoustical fenestration test reports to ASTM E90 as tested on representative assemblies. With revised submittals, PlyGem should confirm in writing that their shop drawings fully conform with specified acoustical requirements. This is not actually for this project. This is for the project that was prior to this, and this is what we were struggling with the acoustical engineer as we're quoting the project that I'm using as an example. And so we added a statement to our shop drawings where we're saying, okay, we're going to send windows for testing. 6 lam, 13 6 glazing will be supplied to target an expected OIC of 32 as per. I erased the name of the building of the consultant here. And it says ASTM E90 testing is planned but will not be conducted until May at the earliest. Actual OITC may vary when reports are available. We got the test report. Yay. Here I'm all anticipating the cover page of the test report, and I'm anticipating and I'm flipping through the pages, and I want to see what we got. We got OITC 28. On an expectation of OITC 32. So I talked to the consultant, the acoustical consultant, and I said, listen, you know, this glazing you expected to get 32, it didn't get 32, it only got 28. He said, well, do you want me to send you the report? He said, no, don't send me the report. Read me the data for the various levels over the phone here. And what I'll do is I'll try and compare that data to the actual sound that we recorded on site and see if I can fit it to make it 35 decibels in the bedroom. That was on a Wednesday, and on the Friday he called me and said, no, I can't do it. No, you know, I'm sorry. And I said, well, what do you want me to do here, you know, with the customer? And he says, just don't respond to them anymore and see if they go away, right? Hopefully they'll forget about it. Because I got this email from the customer. Hey, Dave, please send the testing results. We need to send to the architect so he can send his final documents to the city. Urgent. So I'm like, put that in my junk email. And then a month later, it's like, hey, David, what is going on with this? You promised this a month ago. Is there anyone else I should be asking? Plygem used to be our go-to window guys. Disappointed. With the emoji, the disappointing emoji. So at that point, I phoned the gentleman and I explained the situation and how delicate it was. And I said, did your architect, in fact, sign off on this? And he said, yeah, the architect actually did sign off on it without the report. And I said, well, I would suggest that you start ignoring him and hope that he goes away and don't bring up this topic. So that's what we did. And we also discussed all of the projects that we'd done with them previously where we provided this glazing for OITC 32 and the fact that nobody was complaining about the sound levels in their building. So the windows must be satisfactory to the customer, although a lot of those projects weren't facing like a 4-lane road like East Broadway.
Hey, Dave.
So what
Dave.
does a test report for a product with a Sorry, Anton, you have something to say?
Yeah, just to provide a comment to that, because I think that sort of played into the architect did eventually sign off on the project without the acoustic, the outdoor to indoor acoustic data, correct?
That's what happened, yes.
Yeah, so which is kind of goes to my point is there is no architectural sign-off requirement to meet this criteria. So that architect likely came to the conclusion that, okay, great, we got this acoustic criteria done. We meet the criteria for the development permit, which doesn't have a sign-off requirement for occupancy. So it all kind of, this has been my experience, like what you just described there has been my experience in 90% of the time on these types of projects. The challenge with it is it's scary. You don't know until you get to the very end of that kind of critical point where people are pushing you to say, I need this, I need this. The other part of this conversation is the acoustical consultant provided an IGU configuration that they assumed would meet OITC 32. So they specified a Lamy 13 millimeter airspace, 6 mil glass combination. And then also said it most likely would reach an OITC 32. But they're basing that on some data that they've developed over time. And I question an acoustical consultant says, how do you know that that glass configuration in my frame is going to meet that OITC number? And he goes, oh, we're basing it on historical data. Every single acoustic test I've ever done, and I compared it to what an acoustic consultant had assumed it would meet, none of them matched. And so I think one of the biggest challenges that we've had is acoustical consultants are using data for prescriptive specifications like this, assuming it's all going to be good, and then it falls short. And my personal experience, the only way to get a window in excess of OITC 30 and above is to have a 1-inch airspace or greater in a window. It's the only way to pull it off through the research that I've ever done. So as soon as I see a glazing spec with a 13 millimeter airspace, typically what I've seen is it'll never hit anything over OITC 30. So it's just there's a big gap, I think, in the design community. But what the architect did in this case, in my opinion, was the correct action, which is a good thing to see. But the only problem is when you go into these projects contractually, you're in a way rolling the dice depending on how the enforcement's going to be. So that's the cautionary part to this conversation.
Thank you, Anton. And so this is an example of a unit that we had tested some time ago, back in 2024, in anticipation of projects where they might require very high OITC ratings. For instance, if your elevation is facing a future SkyTrain station, they're going to want even higher than 32. They're going to want 34, possibly even 36. So we experimented to see what we would get with 11.7 millimeter Lamy on 14.5 millimeter argon on 8.6 millimeter Lamy at the the OD of a triple glazed unit. And it got OITC 34, and you can see the frequency so this is the sound pressure level in decibels, and I think And so you can see how it's got quite high numbers in the lower frequency range and somewhat lower numbers in the higher frequency range. And that's what you need to see in a report in order to have a good OITC. So how does this one compare to my OITC 28 rating? This is the problem right here. And this is the transmission loss in decibels between the transmitting room and the receiving room. And you can see down in the lower frequency ranges, you got 27, 20, 25, 17 at 160. This was the data point that the consultant said killed us and that he couldn't fit the data. And then, but up in the higher frequency ranges, you're at 41, 40, 37, and that type of thing. That's the kind of thing that you need to see there. And so we hadn't had the chance to develop and test something that would get you 30, 32 yet. We actually sent a bunch of different units out for testing, and half of them got lost en route. So the only one they tested was the one that had the really highest rating. And so we tested, what does it take to get OITC 29? So we tested 7 millimeter lamy, that's 3-on-3 with 60 thou laminate layer, on 14.5 argon on 4 millimeter glass. We got OITC 29. And, so that is also something where you could get a reasonable U value. You can only put one low E coating on a window like this unless you want to pay for low E laminated, which is frightfully expensive. So we put the low E on surface 3 on the 4 mil pane and got a decent U value together with OITC 29. And so that 6 annealed on 16 argon on 4 mil got OITC 28. So that'd be where you could potentially get 2 low E coatings onto this unit for a lower U value. So it seems like having one thick heavy pane on a thinner pane with larger air spaces are the trick to get a decent OITC up to around the 29 region. So what would it take to get OITC 32 for the project that we were currently quoting at the time that I made this presentation up? We were willing to test 11.7 millimeter lamy on 4 millimeter to see if that would do the trick. But first we needed to determine the cost for that and see if that was something that the building owner would be willing to bear. Not sharing any confidential pricing and market information here at Windor. Let's just say that it's in the lower end of hundreds of thousands of dollars, and the building owners are very cost sensitive. So a difference in cost of $10K between equivalent bids can result in the lower bid being awarded the project. So these are the results. Okay, so we had these 3 unit types, and I'm saying, what is the difference in cost to the customer of upgrading to 7 mil lamy on 4 and 11 mil lamy on 4 for the glazing in these units, up from the standard glazing, which is 3-on-3 glazing in the top lights and 4-on-4 tempered inboard on the lower lights where it needs to meet guard loads. So for the 2 light units, to change to 7 lamy on 4, 1.4 times the cost. To change to 11.7 lamy on 4, 1.90 times the cost. 4 light units, 1.44 times for 7 on 4, 1.97 times for 11 on 4. 6 light units, 1.497, we'll call it 1.5, and over double the cost to 11.7 lamy on 4. And we presented this information to the customer, and they had a very stern talk with the acoustical consultant about what the priorities were on this project. You can't be doubling the cost of the windows in the bedrooms on the side that is facing the road. It's just not going to fly, out there. So how did this wind up getting resolved? Oh yeah, this is just what I said. And so the other thing was the architect, and we talked with the builder and the architect to discuss the cost implications, and the architect in turn talked to the acoustic consultant and building energy modeler, as their original U-value specification of USI 1.3 would not have been possible with laminate glazing, as it would have required 2 low E coatings, and laminated low E glazing is extremely expensive. The units were sitting at USI 1.53 in all of the glazing options, including 6 lamy on 6. In the end, the acoustic consultant was more or less forced to accept 6 on 4 to meet OITC 29 and 6 lam on 6 for OITC 32. On the 4 light units, 6 on 4 came at a 17% cost increase and 6 Lammy at 6 at 45% more, but only in the bedrooms facing East Broadway. And this was the final statement by the acoustic consultant to the architect. Japheth, as discussed, Plygem's windows and exterior doors proposed in this project. We understand the specified fenestration acoustical test reports are not available. BSA, sorry, I forgot to erase. Anyways, now you know who the consultant was. Confirmation of acoustical performance requires the specified test reports. If considered necessary, they can evaluate acoustical test reports on file from other window and door suppliers for assemblies with similar IGUs and provide comment just, re the window and door assemblies proposed by Plygem. For reference, laminated glass is often required to meet the specified OITC 32 rating. So now this will be their kind of statement that they're going to make going forward when they run into this type of thing. So where do they get their numbers from? I suspect from Starline, who had extensive acoustical testing. And they are saying for their 7100 series casement and awning windows, 6 millimeter on yield on 6 lam with a 19 millimeter airspace gets some OITC 33. 4 on 24 mil airspace on 6 mil lam gets you 32. And and they got another more specialized laminate glazing that gets you up to 33. But so realistically, so they would have read this OITC 32 and ignored the airspace, and that's where they got their numbers from.
Hey, Dave.
Go ahead, Anton.
So this is exactly where I start getting into acoustic consultants are operating in a vacuum in a way, or in a silo, where they see this information and go, it can be done. So key factors here, and I've seen this before, and I did my own testing on this. 24 millimeter airspace, what impact does that have on thermal performance, right? You're introducing convection current, so now you have an impact on your U value. Laminated glass inboard. Glazing engineers designing windows to guard load cannot use laminated glass for dealing with load. They have to use tempered glass. So this potentially opens the door to having to use Lamy tempered as well. And then you talked about low E coatings on Lamy glass. One of the things that's actually helped me navigate this with architects, especially when you have like a bedroom window that would need this glass, and then the living room window beside it that's not Lamy, is it changed the reflection color of the glass. And I had a project many, many years ago where this happened. And when you put a low E coating on Lamy glass, it starts to change the color of the glass. And architecturally, it starts to make the building look a little bit odd. So there's a number of factors going on here that I think need significant coordination. And so anytime you see, and what you just explained, an acoustical consultant grabbing this information and using this as their baseline, as their rationale to say it can be done, it doesn't necessarily mean it's a good thing to do. So the other factor in here is weight. Some of these windows can get extremely heavy with this glass. And when you're talking, an 11 millimeter laminated unit, you have to start now talking about sash size reduction. And so I've run into issues where, they had 36-inch wide casement sashes, expectation of them opening 90 degrees with Lamy glass. And I'm like, we got to put a 4-inch restrictor, or we got to reduce this window size to, 24 inches to deal with that weight of the glass. Well, it's too late. The project's designed, it's drawn up, they've got their aesthetics all figured out. They can't change that at that stage. So there's so many coordinating items with this issue alone. And I would caution anybody, when you're bidding on a project, if you see this, you're going to have conflict at that shop drawing stage no matter what. So you can either choose to preemptively deal with it, which can be frustrating at the bid stage because you might be the only one bringing it up, and other window companies don't bring it up and hope to deal with it later on. So this is having this conversation now, I think, is a very, very important one, because this information on its own is great, but it doesn't work with all the other code requirements that we have. And that brings me right back to the idea of development permits cause conflict with building code issues. And that's why, in my opinion, acoustics becomes a big issue. 20 years ago, 25 years ago, the way we dealt with acoustics in buildings is we put in a standard window in a building, and then 2 inches inboard of it, a single pane, 6 mil laminated piece of glass was glazed on the inside of the window to create that acoustics. We've tried to kind of combine acoustics into a standard window, which has created this issue that you basically explained today.
Thank you, Anton. And that was our last slide. So now we have time for questions and discussions. If somebody wants to put their hand up, anybody got any comments or questions on this presentation or about acoustics? Maurice Quinn.
So I've got 2 comments, really. First off, great presentation. Thanks, guys. Anton, Dave, always really, really good. Much appreciated. The first thing is every engineer you deal with is a math monkey and a model tard. This is a person who builds models of reality, and every single model they will ever build is incorrect. All models are wrong. Some models are useful. If you get a stupid answer from an engineer, push back. I take phone calls for free. I really, really like smacking down the stupid comments from the average monkey engineer. All models are wrong. Some models are useful. And this presentation does just about the best job of pointing that out. May I please have a copy of this for my staff?
Absolutely. And we're even recording this here. So this is a presentation that you'll be able to review later. It will be available online, Terry. So yeah. Kyle Cartwright.
So
West Tech.
yeah, go ahead.
I think the important part, Maurice, there is you talk about engineers, and if you talk to developers, they'll say we've never had to have more consultants on a project than ever before. They're pulling their hair out. They're going insane with how many design consultants, which in most cases are engineers of some kind. What's missing in everything is coordination. So it's not the engineers that are, in my opinion, are the problem. If you hire an engineer to design something, they're going to design something based on what their expectation is. What's missing is the person who says what's most important. And the other part is the person who's coordinating has to say life safety is more important than acoustics. They have to say energy requirements are more important than acoustics. Is aesthetics more important than acoustics? I don't know. So the role of the architect, in my opinion, from a coordinating registered professional is the single biggest important part to solving these problems. So we have to, as an industry, stop trying to solve these problems and actually go back and say, architect, it is your job to coordinate this. And if you don't know how, you have to question your professional responsibility on this project. That's the conversation we need to start having more frequently.
He's not wrong. Yeah. Kyle, go ahead.
Thank you. Maybe 2 comments and 1 question. Today and other conferences, we keep hearing about consultation and dealing with things ahead of time. In the same manner as we hear about that last year and the year before. Maybe a question to Dave and Anton, are we seeing more of this or is it the same old? And then also, how does air tightness for a window product factor into the acoustics? We all agree that if the window's open, you can hear through it. One product leaks more air than the other. Is that accounted for or considered at all?
Yeah, I can answer that question because North Star has done quite a bit of testing of different window types, including double hungs. And of course, a double hung window is going to have a lower OITC rating than a casement window because of the crack length and the fact that it's not a compression seal. Hussam, do you want to say anything about this? Hussam's the guy who did all of it. Anyways, putting him on the spot. I'm trying to get him up here at some point.
We will. No question. So model tard is the one politically incorrect comment that we're going to allow this window. So we're done. That's behind us. Any more questions on this? It's again, we're talking about something that's happening in Vancouver where it's increasing, but everywhere is densifying, right? All the cities are densifying. Mass transit is becoming greater. So this is coming to your neighborhood if it's not already there. So start thinking about how to deal with it.
These ratings, they're based on window-specific configurations?
No, they're standard size windows, a little bit like the NFRC system that they want you to test. I think it's 600 by 1200 for a single light window and a 1200 by 1200 for like a slider window. Yeah, and so they're not reflective of the actual acoustical performance, particularly if you've got mullions and those mullions have steel rebar in them. We don't want to know what that does to the acoustical rating and the transmission loss. It's probably not going to be very good.
I just have, you just answered one of my questions, so thank you for that. And the other thing is, as far as, using the laminate, the 7mm laminate on the exterior, how much of a performance can you get to the inside light as far as a low E coating before you just put some destructive elements onto that laminate?
So you need two low E coatings in a double glazed unit to get you below like 1.53 and get you down into, I think, like the 1.4 range. I'm not sure. But the laminated glass is already ferociously expensive, and low E laminated glass is even more expensive. I don't know about triple glazing. North Star did some testing of triple glazing, but it was 3 on 3 on 3 and 4 and 4 and 4. You're not getting up into the 40s in any of those glazings.
But what do you do to keep the laminate from breaking?
To keep the laminate from breaking? Well, nothing. It's just laminated glass, and so it is safety glass in the sense that if it breaks, it's not going to leave the opening.
You talking about thermal impact?
Yeah, I'm talking about.
Oh, okay.
The glass finally cracking and.
Yeah, I don't know. We don't have data for that. We just
Okay.
don't have enough experience with that. But I haven't heard anything back. We've been using 6 Lamion 4 and 6 Lamion 6 for years and years. This acoustical consultant thing is going back at least 15 years.
Yeah, I just did a job where I had 6mm laminate with equivalent of a 366, let's say from Cardinal, and the laminate is cracking.
Oh, that's interesting.
Well, yeah, if you put something like 366 on surface 3, you're creating a significant chance of heat breakage. And Cardinal has a table about all of this and the combinations of low E's and what what higher percentage of breakage that you can expect. But it's generally tailored not towards laminate per se, but
in this case it's laminate. So I was just wondering, for acoustical reasons, when we go ahead and we do this, we also have to look at the whole aspect of, is the sealed unit going to stay intact?
Yeah.
Mm-hmm. That's a great question, and I don't have an answer.
Yeah, that's what we.
I mean, so the solution for heat cracking, thermal cracking, is to temper the at-risk light. But again, laminate.
Tempered Lamy low E. That's really cheap.
Yeah.
That shouldn't be a problem at all getting that.
It'd be a 500% increase in your window price.
All right. Any other questions? No? Dave? Oh, you got one? Go ahead.
Yeah, I was just going to say, one of the difficulties with triple glaze, like he's talking about, in combination with the Lammies, is, and you require a 1-inch airspace.
Yeah, that's not going to work. And so the thing is, if you go to Starline's website, they do have triple glazing, sound abatement glazing available in their commercial products, and the sealed unit is 40 millimeters thick. So you're not going to see that in any residential system.
Yeah. There are some passive house residential products that are getting up into there, 36 millimeter roughly. So, but yeah, it's, to get those numbers, airspace is everything. And trying to get airspace in a triple in a residential window is challenging for sure.
Well, yeah, I mean, so for example, 6 Lam on 6 got 28, but 6 Lam on 4 got 29, and 6 on 4 got 28. So it's the offsetting glass thickness and the airspace is going to be what's going to get you there. And how to achieve that in triple? You better have a glazing cavity that can take a 40 or a 50 millimeter thick sealed unit.
Sure. Okay.
I don't know vacuum glass, and that's a very good question.
Yeah. That.
One
I don't
final
know.
comment, if I could.
Yeah. Go ahead, Anton.
A lot of the data, the acoustic engineers, is old data, and I was involved in a project 20 years ago by the YVR airport where there's a 2-inch airspace in the glass. And the reality is before when we didn't have energy codes, it was quite easy to meet these acoustic requirements. But with the introduction of energy codes, like we're talking about with low E coatings and airspace dimension sizes, this is what the acoustic community is not aware of. And they're not understanding the impact that their requirements have. So when we start talking about all these different IGU assemblies, the studies that I've done and the research I've done is the best IGU assembly you can put into a window is a double glazed Lamy with 6 mil with a 1-inch airspace. So you're basically glazing in a double pane window into a triple glazed glazing pocket. That'll pretty much get you the best outcome you can possibly get in a residential window, but it creates conflicts everywhere else. So it's you can come up with really good acoustic solutions all day long, but it doesn't mean they're going to always work for other requirements.
Yeah, if you're going to have a 24 millimeter airspace, those lights better be very rigid, because the amount of blowing you're going to get as the barometric pressure changes, and let's say you're making the sealed unit at sea level and shipping it to 3,000 feet or vice versa, it's not going to be a practical thing unless you have like breather tubes and stuff like that in there.
Okay. I think that's it. So Anton, thanks for joining us. Sorry you couldn't be here with us, but appreciate your input always. And Dave, thanks very much. All right. Thank you very much, guys.